we left off on Thursday. We finished up hip and valley jacks and the decrease and stairways. There's a quiz out there for today on hips, valleys, and stairs. For stairs, all you really have to find is the number of rises, the number of treads, the unit rise, and the stair opening. For hips and valleys, careful, if there's a different decrease on each side, make sure you find both decreases. I'll give you this. 2 of the problems will be conventional, 1 conventional hip, 1 conventional valley, so there will only be 1 decrease on either side. The other 2 will be unconventional, meaning the slopes will be different, so you have to have a different decrease on each side of the road. Make sure you're ready for that. If there are any questions on it, we can go over some of those in class tomorrow. Those are tough. It's a tough quiz. So today we're going to look more at roofs. We're going to go back into this packet. I'll post another copy of it on Blackboard. Put it up the camera so Isaac can see it. This one here that has all the measurement operations on the front. It's a little bit of overkill on trusses, but where the similar triangles and stuff come in, roof systems is really a huge application of it. And we've done the basics so far, like finding the height or the length of the common rafter or the top chord of a truss or whatever. So today we're going to look at adding in some extras. We've been doing wireframe trusses or rafters like that, so there's no thickness to the members. One of the things that's unrealistic here, this height, which is 0 in this, is called a heel height. That doesn't look right.
Oh, it is like that.
My spelling is horrible. There's a reason I teach math on that. Or art, for that matter. That's the heel height. Well, these have had no heel height. They were using a wireframe drawing. So what if we add in, not quite so loud, a little bit of heel height to this. Let's say that this is 8 inches high. This, let's give it 7/12 slope on a 38-foot span. I want to find 2 things. I want to find height, and I want to find that top chord length. Often labeled J, by the way, in the truss industry. Well, here to do this, I have to force a right triangle in here. Right now, this is not a right triangle because that heel is cut off. So what I'm going to do is this. Cut it like this, right here. That's a right triangle, isn't it? What's this distance here? I'm going to find this distance. It's not the height, so I'm just going to call it A. I can find that length A by using my slope. It's a 7/12 slope. Is A the rise or the run? Rise. So does it go on top or bottom? Top. It's rise over run, right? What goes below it? 19. So 7/12 is equivalent to A over 19. So we're going to cross multiply and divide. 7 times 19 divided by 12. Gives us 11.083. Of course, that is feet right now. Convert that into feet and inches and 60. Okay? That's 11 feet. Subtract off the 11. Multiply the remainder by 12 to turn it into inches, which is going to be 1 inch. That's 11 feet, 1 inch. That's not the height. How am I going to find the height from that? Add 8 inches to it. So what does that give me? 11 feet 9 inches. So my height is 11 feet 9 inches. Here's the part where people make most of their mistakes here. Find the top chord length. Obviously, I need the 19. Do I need the 11 foot 9? No, I need A, the 11 foot 1, or the 11.083. That's what I need to find the top chord length. So I'm going to find that top chord length is going to be the square root of 11.083 squared plus 19 squared. Put a bunch of extra 3's there because it was 21.996 feet. So we're going to put that into feet, inches, and sixteenths. So I've got 21 feet. What do I do with this from there? Back to 21, and then 12 gives me 11.956. That's 11 inches. Then what? Back to 11, and then times 16. Well, I get 15.3, so that's 15/16. 21 feet, 11, and 15/16. What if that had been 15.6 instead of 15? Rounded up to 22 feet exactly. Any questions on that? Let's talk about heel height for a second.
Hey, so when you're talking about your truss, you
Yep.
know how manufactured trusses always have the tails that stick down?
Yep.
Are we ever going to talk about those?
That's coming. That's the next thing we're going to add is the tails. Heel height on a truss. Yeah, those are the ones, the quick references. Heel heights on a truss come from the thickness of the lumber at the most basic level. Common heel is calculated on a 2x4 top chord. I'm just going to draw out the basic layout of a truss. This is no webs, no overhangs here for right now. So a common heel is based off of this being 3.5 inches wide. So what we get down here, what we have is we have this distance here, which is the angled cut of that 2x4, which depends on the slope. The bigger the slope, the longer that angle is. For a 412 slope, I think it's 4 1/16. Oh, it's 4 3/16. Actually, that's the total heel height. It's not the cut. But there's also a little bit, you can see down here, this board does not just come to a perfect angle. There's a little flat cut there. That is 1/4 inch. Called the butt cut. You don't need to know that. What it's for, if you're cutting this with a saw, if you try to cut exactly at the corner, the saw hits the corner, and what does it want to do? It wants to jump or deflect. It might go this way, it might go that way. It's hard to predict which way it's going to go if you aim exactly at the corner. But if you aim 1/4 inch from the corner, you know the saw is going to deflect slightly this way, but it's predictable, so you can adjust for it, and you get that perfect cut. So that's why you have that 1/4 inch there. So it's that 1/4 inch plus the angle cut that gives you the heel height. That's where the 4 1/16 comes from, 412 and 4 3/16. That's a common heel based off a 2x4 top chord. Type A heel is based off of a 2x6 top chord. Common. Now type A heel, same situation. Now this is figured as this is being 5.5 inches across here, the 2x6 in other words. So this is still 1/4 inch. This is now larger because it's a 2x6. Well, with modern trusses and modern lumber grading, and obviously there's webs to reinforce them, they don't need a 2x6 for the top cord. So they can still get away with just using a 2x4. So what they do is they'll just put a 2x4 in here instead of a 2x6. Then the bottom cord will just be cut, the bigger butt cut in it so it sits together. Most of the time it ends up exactly like this too, so that they barely touch. So they'll put a wedge in here, so that when they plate it, there's something for the plate to hold. Getting larger than that would be a type A or a type B heel. Type B heel is not based off of any particular top cord. It's anything larger than what the 2x6 heel would be, or the type A heel, up to 12 inches. Those are typically framed like this. You have a vertical web there, and then the top cord sitting on it. So if this is less than or equal to 12 inches, it's type B. Greater than 12 inches, it's type C. This area, heel height is important. Can anybody think of? So is part of it. Wind, not so much, but it could play a factor.
Ice.
So when we sheet this up here, what's that?
No.
You actually had an idea there.
The ventilation.
Ventilation. Okay, so when you frame this up, you're going to have your sheeting on your roof, right?
Yeah.
You're going to put, they call them proper vents that stick out here. So the air can flow through that top 3/4 of an inch or so. Then what gets packed under here? How thick of insulation do you usually put in your ceiling? And that is usually 12-inch thickness. If this heel height here to here is only 4¼ inches or 4.5 inches, you're not getting 12 inches. Even if you go to a type A heel where it's 2x6, and type A is what's most commonly used around here to get that little extra height. Still only getting 6 inches of insulation out there instead of your 12. So realistically, you should, they call them an energy heel, one of the names, slang for them. Get that up there to that 8, 10, 12-inch heel so that you can get insulation out there. If you go into a hole with Scott's infrared camera, if you look up at that joint between the wall and the ceiling, it'll almost always look cold for about the first 6 or 8 inches out from the wall on the ceiling.
So for a proper vent, are those like the?
That's just that piece of foam that's kind of.
Yeah. You just stick down in there and they staple it to the.
Yep. Yeah, you stick them down in or shove them up from the bottom and staple them in.
It just allows air to flow up to like the.
Yep. Yep. That's all that's for, so air can flow through. If you don't want to use those, you don't have to. You can actually just put end ridge vents on and run it through, but it's much better to have it vent from either. What they found is if you just put ridge vents in the end of the gables, you have to have electric fans in there to force the airflow. But if you have the vented soffit down here with the proper vents and then a vented ridge, the hot air itself rises, so the hot air will leak out through the ridge vent and it'll pull cool air through your attic without having to have electric fans. The modern, depending on what region you're in, there are some regions where they seal the houses up just tight as you can and put a bunch of vents. And we're talking kitchens, bathrooms, everything, and then attics and everything to vent them so that they can control the airflow throughout the whole house. The problem is that you got a lot of electricity for running vents. There used to be at one time, you guys, like, we'll do sheetrocking on the garage, or we'll be doing some sheetrocking on the garage of the house. One time they used to say you either put vapor barrier on the walls or the ceiling, but not both, because it sealed the house up too. Now they're saying seal it up tight and just vent it. Got off topic there a little bit. Let's get back to our trusses. So then the next thing is exactly what you'd asked about.
Closed in a year.
That?
I said my bathroom or my bedroom window haven't been closed in a year.
Yeah.
Even cracked, they worse. Haven't died yet.
Code for a bathroom used to be you had to either have a window or a vent fan. Now you have to have a vent fan.
See, I just don't like the idea. I mean, my walls are like 4 to 6 inches thick. It's not impressive. I throw a vent in that bitch, and it's going to be cold as fuck in there.
Well, you have a fan. You have to have a controlled vent, a louvered vent, and a fan. Most vent fans at the bottom, you have the box in the ceiling for the vent fan. They're louvered at the fan, so that it's not supposed to allow a backflow of air, but they do. Then they're louvered at the outlet of the house, so that's not supposed to allow a lot of air to come in. So you don't get a lot, and then the vent itself, a lot of people screw up when they install bathroom vent fans because they insulate the attic and then they run the vent above the hose or pipe or whatever for the vent above the insulation and out. You end up getting a lot of moisture back in, and you get a lot of mold around the vent fans or mildew around the vent fans because that hot, wet air coming out of the bathroom hits the cold air in the attic because it's above the insulation. Dude, vents. Water, you get water, so that pipe should go up and then slope down to the outer vent so that anything that condenses runs out. But it should also be insulated. It should be underneath the insulation or extra insulation over the top of it. If it goes up high, it should be wrapped in insulation. Some houses, they just run them straight up and put a roof mount vent in. They should be wrapped in insulation so that they don't. I'm not a big fan of roof mount vents because gravity, exactly. And if your roof is covered with snow, if you run the vent every day so that it keeps the snow melted off and keeps open, that's one thing. If you go a couple of days without running it and it gets covered with snow, all it's going to do is freeze an ice clump and then the moisture is going to start.
Yeah, I like my mold where I can see it and get rid of it.
I like on mold, I like those on cheese.
I bet you do.
So let's take a look at overhangs here. Let's say that we have a 34-foot fan with a, let's go 612 slope. We're going to find the height here and that top cord length. The height is not so bad. The slope is 6/12. What's going to be our other ratio? And there you go. Half of the 34. Cross multiply and divide. 6 times 17 divided by 12 gives us, what, 8.5 feet? Half of 12. So not as bad as it was. I may look like I knew a lot of quick math, but there's tricks to a lot of it.
I was starting to do that, but then instead of Bruce. I would never.
Let's say we've got a 2-foot overhang here to keep this simple. To find that top cord length, you've got to find a completely new triangle. Triangle is going to look like this. This triangle has a new run. How big is it? 19 feet. Good. It's the 17 we had here plus the 2-foot overhang. And we're going to have to find a rise from that. We can call this whatever. We'll call it y. So what's y have to be there?
8.
9.5, there you go.
Yeah.
That's 9.5 feet. So what, to find this top cord length, we are using that 9.5 feet of rise from the bottom of the tail and the 19 feet of run. Square root of 9.5 squared plus 19 squared. Gives us 21.243. That back to
It's gonna be
21
almost 3 inches.
times 12 is going to be 2.91. Yep. Back to 2.
2 and 15, 16.
Oh, it is 15. 14.5 rounds up to 15. Good call. 21 feet, 215, 16 inches. Now, where this gets, right now, the 2 foot is a 2 foot or 1 foot is a standard overhang. But some contractors, when they'll special order a truss, they'll do this. This is 42 feet. Make this 8 to 12 slope. Why would they make that, order that at 22.5 inches of overhang?
They'll let whoever they're contracting do the math.
Something with the soffit.
What's
Yeah,
that?
it's something with the soffit. When you put your fascia board on, then it's
There it is.
24.
You know, if you're gonna use a 2x6 fascia board, it puts you at 20. You don't have to, as long as you set your trusses with the tails lined up, you don't have to trim your tails. To be honest, that's one of the jobs I hated the most too, is going up there on the ladder with the skill saw to cut those tails, because it always spit the sawdust right back all over your face. Hated it.
On the string line, go up there with your square and
Yeah.
square them on quick. And
I always just, that's what I always did, was ran a single string line, ran a square. I know a couple people that actually run a top string and a bottom string for it. I don't think they got it considerably straighter than I.
you're moving the board the whole way down anyway, so.
Yeah. So we're going to find that height and that top cord length here again. The height is going to, well, you guys tell me how to find the height. Well, okay. Perfect. 21 is just this length here. That runs. Cross multiply and divide, we get the H is 14 feet.
Three
What?
quarters.
Yeah.
Never mind.
What are we going to do? Stick our top cord here now. In this triangle, I'll call this Y here. I'm still going to use 812. This will be Y. What goes down here?
Oh, man. 23 feet and a half, 23 and a half feet.
I'm going to take my 21 feet and I'm going to add 22.5 inches over 12 to it. It actually comes out to be not a horrible decimal. It's a, well, it comes out to be 22.875, I believe, if I remember. There it is. 1.5 inches is 1/8 of a foot. So by subtracting that 1.5 inches, I subtracted an 1/8 of a foot. So instead of 23, it's basically 22.7. 1/8 of a foot. Yep. So we cross multiply and divide there. The 22.875 times 8 divided by 12. We get 15.25 feet of height. So to find that top cord length, it's the square root of what? 13.25 squared plus 22.875.
You know, I hope the engineers just have a program where they type in like two numbers and they figure this all
They do have some programs for it. The thing is, in the truss industry, they have certifications, level 1, level 2, level 3 certification. What you're allowed to do as far as design work is based off your level certification. Get those certifications, you go off to week-long classes, then you take tests at the end, a week or 2-week classes, and you take tests at the end. This is the type of calculations on the test. Actually, these problems I have here, I used to do some of those 2-week training sessions. These come directly out of the literature that we use for that training.
we can design trusses now.
Possibly. So like says 27.492 feet. We're going to leave it at that. I'm going to trust at this point. You guys can convert that into feet inches. I'm going to stop doing that for a while now. Let's
My house direction.
do both of them at once now. I will go to a separate page here. You know that looks halfway even.
Way better than mine.
We're going to give this a 6 1/4 inch of heel height. I used to have a banner before we put this soffit in. This soffit was put in 6 or 7 years ago because they did a new heating system through here. That used to go all the way up to the drop ceiling. I used to have a banner above my board that said objects on board are not drawn to scale. Just because my scale is pretty horrible on some of these.
I measured it.
You can figure it out.
I just put the same height as it.
16 1/4 inches is bigger than a 16 1/2 inch overhang, but you guys get the picture. So here, I want to find the height. I want to find the length of the top chord. Have any ideas where to start?
I'll do the 10 over 12.
10 over 12.
Yeah, that's a good place to start. Put your H on the top on your numerator.
Careful.
Gotta do A.
Got to put in a special, then we'll call it A. It doesn't matter what you want to call it, but yeah, we'll call it A over.
I didn't see an A.
So, just have to make something up and put it in there for that.
Yeah.
A over 14, right?
Only because then we'd add the 6.
You have to add the 6 1/4 inches to it. So 10 times 14 divided by 12 is 11.667. That's 11 feet, 8 inches. 2/3 of a foot is, of course, 8 inches. I don't expect you to memorize all the fractions of the foot, like the 1/8 of a foot being 1.5 inches. That I'm not so concerned, but I do expect that you get to where 3 inches, of course, is what fraction of a foot? 1/4. 4 inches is 1/3. 6 is half. 8 is 1/3, and 9 is 1/4. Those are the ones. I'm not going to quiz you on them and test you on them, but you really should get those memorized because it saves you a lot of work in your calculations. We have 11 foot 8 inches is A, plus 6 1/4 inches. 8 and 6 1/4 is 14 1/4, which is bigger than a foot. So I'll carry 1 foot. How many inches would be left over? 2 1/4. We would subtract 12 inches from it. So 11 plus 1 is 12 feet. So that's 12 feet, 2 1/4 inches is my height. 11.667.
When you make your triangle, it's gonna be off the bottom of the home, so they're just gonna come straight
Yeah,
across.
it's gotta, yeah, it's gotta fit the hypotenuse, so it's gotta come straight across from where the heel intersects the top chord there, yep. Now to find the length of that top chord, you gotta find another triangle altogether that has nothing to do with the height. Do that red triangle. Brought down here. Call this Y. What's this length down here?
Wait, no, it's
28 feet. Oh, it's not 28 feet, it's 14 feet.
Yeah.
Thank you.
15.
Good catch. It is 15 feet, 4.5 inches. Half inches. So we want to convert it into a decimal number of feet. So to do the decimal number of feet, we take our 14 feet, which is the run here. That would be this distance. We're going to add the 16.5 inches, so it's going to be 16.5 over 12. So that we come up with feet here. 14 plus 16.5 divided by 12, we get 15.375. So 15.375 feet is that bottom piece. And we're going to find Y. We're still going to use 10-12 slope. What's my proportion going to look like? Over 12 equals Y over 15.375. So 15.375 times 10 divided by 12. 12.8125 is our height. How do we find our top chord length now? Figuring theorem, the square root of 12.8125 squared plus 15.375 squared, and we square root the result. .014 feet. What do you think? We're having fun yet?
So do we have to find a smaller triangle first?
It doesn't matter which one you find first. You can find this one first if you wanted to. The only reason I had to find the smaller triangle is because I asked for the height too.
Well,
Yeah, the smaller triangle doesn't help you at all with the bigger one for the top.
that's what I was wondering, like, whether there's some.
So those are two totally separate things. I think she's expressing her affection for mathematics. Not the worst sound I've heard coming from a student. Put it that way. An addict truss. An addict truss typically has a larger heel height. It has a larger heel height. Get the top chord up away from the bottom chord. And a relatively steep slope. I have seen a couple at 612 slope, but usually it's 812 or higher. Oh, it sucks. Twelve is what they want. 12 is kind of an awkward. I don't mind up to like a 7 or an 812. From there, I'd just as soon jump to a 1612. Anything below an 812, you're working down to shingle it. Anything above a 1612, you're almost standing up and working in front of you. But like that 1012, 1212, awkward because you're not really bending over. You're not in front of it. It's a weird position to be. You can't really kneel to do it. It's awkward to work on. It does look nice.
I love it.
Sensing some sarcasm there. On an adit truss, we have some extra things to consider. I want to take that height out of it. I'm going to do this. I'm going to tell you that this wall here, I want it to have at least a 7'6" height. I want to find the ceiling height. I want to find this distance. I'm going to call X. Find C, X, the height, and the top chord length. There are a ton of triangles here. Take a look. Which one do you?
Trapezoids.
Now there are a lot of trapezoids too. Work with them when you try. Pick which one do you want to find first. Do you want to find the top chord length, the height, the ceiling, or X?
Probably
C.
the height.
I'll find. I'll go with the height. That's the one I heard first there. So
That makes sense.
we'll put in this triangle right here. I'll draw it over here. I'm going to call the height of that A, the up and down A. What's this bottom piece? 18. It's still half the span. Good. And it is still an 812 slope. So how do I find A? 12 equals A is 12 feet there. So what's my height? Where did I get the 2 feet 10 inches?
That's the 34.
Inches, you got it. 12 plus 2 feet 10 inches is 14 feet 10 inches. That is my overall height. Now just to clear up my diagram, I'm going to take that green triangle out of there. I want to find J or X. I'm going to take C off the table because you have to find X to find C. Do you want to find the top chord length or do you want to find X?
Probably top chord length, because we're already halfway there.
Landon said X. We'll go with X.
Yeah.
That way it's going to be his fault.
Yeah.
Doesn't need enough information.
Find X. This is the triangle I'm going to use. This is X. We know this is an 812 slope. Do we know this height? 7'6" minus the 2 foot 10. You got it. Over here, the 2 foot 10. 7'6" all the way up here. So this will be 6. This is going to be 18. 8 inches. 4 feet 8 inches is that height, or 4.667. 4.667 feet. So X can be found 8 over 12 equals 4.667 over X. 4.66666 times 12 divided by 8, 7 feet. That X is 7 feet. This is 7 feet. What does that tell us about C? Got 36 minus 14, which is I'd actually pretty much have C. Now to find J, what do we do? This big triangle here. You got it. What do I know about that triangle?
1410 is the height.
Doesn't go all the way down to the bottom. Doesn't always come down here, so it's gonna be a different height.
I thought that
The
was.
length is
Good thought, Bill.
20 feet.
You got it's 18 feet out to here, plus the 2 feet of tail, so it's 20 feet total on the bottom. The middle of the slope is 812. 8 over 12 equals, we'll call that height y over 20. Cross multiply and divide.
At 16.
Thirteen and 1/3 is 13.4. 13.3223. So this is the top chord length. How do we find that? Got square root of 13.33333 squared plus 20 squared. $24.037. And I trust you can turn that into feet inches. Any questions? In that packet now, you should be able to do up to number 66. You guys give me a good hard 10 minutes working on it, I'll let you. Maybe have your packets with you.